Hey guys, it's Miss Hagan and welcome back. This video is for AP Chemistry. Yeah, that's the reaction most people have when they hear about AP Chemistry. But this video is for AP Chemistry, and today we're going to be talking about significant figures, aka Sig Figs. So Sig Figs are not my favorite thing. They are most people's worst nightmare. They can be kind of difficult to work with, and there are a lot of exceptions to significant figures. One reason we use significant figures is so we can talk about the difference between accuracy and precision. Okay, now we have two types of numbers. We have exact numbers and then we have significant figures. Now exact numbers are obtained by counting or by a definition. So a definition would be like pi. What's the number for pi? 3.14, blah, 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 forever and ever. Okay, that is what we would call a definition. But Sig Figs, those are obtained through measurements. Okay, so I do an activity with my students where I have them, I've gotten pasta, and I've taken the mass of all of the pasta, and then I tell them what the mass of the whole thing is. Then what we do is they are each given 10 pieces. They weigh the 10, figure out the mass of one, and from that they're able to figure out the mass of, hopefully, or how many pieces of pasta there are in total. So we do that, we all write them on the board, and then after that we go through and we count them, and then we find out what the exact number is versus the number that we came up with. And we can see the difference between the exact number and what would be the number for significant figures. Okay, so there are some rules for Sig Figs and how they work, and there are 5 different rules. So I'm going to go through those rules with you. So the first rule is going to be this: all numbers that are not 0 are always significant. Okay, so 1, all numbers not 0 are significant. I'm just going to write sig for significant, okay? So that means if I had a number like 54.34, then I have how many Sig Figs? I have 4. I have 4 Sig Figs. 4 Sig Figs. Okay? So that's pretty easy. You're like, oh, Ms. Hagan, I don't understand why people despise Sig Figs. Well, you're about to, okay? So our second one is that 0 is sometimes significant, but not always. It is sometimes significant, but not always. Okay, so there are little exceptions to 0 and how 0 works. Okay, and this is where people get really confused about things. So the first one is that zeros at the beginning of a number, they don't count. Okay, so zeros at the beginning don't count. All right, so here's an example. So if I have 0.043, okay, I only have 2 Sig Figs. The 4 and the 3. The 2 zeros here, they do not count at all. They're not significant. Okay? Don't ask me why that is the way it is. It's just how it is. Okay? All right, so then we have B, letter B. Okay, and letter B, the second exception is that zeros between digits that are like not 0 are significant. Okay? So zeros between non-zeros are significant, always. So if I had like 304.3, I have 4 Sig Figs here. Okay, 304.3. There's 4 of them. That 0 does count, okay, in that circumstance. But then I have letter C. Okay, now letter C says that if a number contains a decimal point and zeros are at the end of it, then they're significant. Okay, so numbers with decimals that have zeros at the end are significant. Okay, so an example of this would be something like, let's do 440.0. Okay, how many Sig Figs do I have? I have 4 Sig Figs. Okay, 4 of them. All right. Right, okay, so this stuff should be pretty, okay, yeah. Now, don't ask me why this is the case up here where the zeros in the front don't count even if there's a decimal, but at the end they do count. I'm guessing it has to do with place value. Okay, and then there's one last letter that goes under the thing about zeros. Okay, and this one is what's going to throw you, okay? Zeros at the end of a number that do not contain a decimal point may or may not be significant. Okay, so zeros are at the end, not in, at the end of a number without decimal may or may not be significant. May not be significant. Okay, so an example of this is if I had 24,300. Okay, so I could have a variety of amount of Sig Figs. I could have 3, I could have 4, or I could have 5 Sig Figs. All right, this is going to cause problems, right? One reason I think this is like this is it's going to try and make you have to find decimal points and use decimal points. And those are your friend, okay? Now, number 3, our third rule, is that exact numbers, so remember I told you exact numbers are things that you count or numbers with a definition like pi. Those can be considered as having an infinite or unlimited number of Sig Figs. So think about pi. Pi can have a butt ton of significant figures, okay? Exact numbers have unlimited Sig Figs, okay? And we only have 2 more things to do. Actually, it's just really 1. All right, so I'm going to go ahead and erase this. So our second and last one rule for this has to do when we do math. So when we're adding, subtracting, multiplying, or dividing with significant figures. Okay, so our last rule states that if you're adding, subtracting, multiplying, or dividing, the number that has the lowest amount of Sig Figs is going to determine how many significant figures your answer will have. Okay, so the best way for me to show this is to give you an example. So let's do an example. I have some right here. We're going to do them together. So if I add 37.4, oh wait, let's do 24. I'm going to put a 2 right there. Boop, milliliters. And I add that to 10.3 milliliters. Okay, so here I have how many Sig Figs? 4. Okay, and on the bottom I have 3. So that means my answer is going to have 3 Sig Figs. Okay, so when I add this, I get 4, 5, 7, 4. Okay, so 47.54 milliliters. Okay, but that's 4 Sig Figs. I have to get rid of 1. So I'm going to get rid of this 4. Now, the 4, I am not going to round the 5 up because 4 is below 5, right? So it's going to end up being 47.5 milliliters. That is my answer. Okay, same thing when you multiply something. So let's say we're multiplying. We have 12.34 centimeters, and we're going to multiply it by 1.23 centimeters. Okay, so here I have 4 Sig Figs, and here I have 3. Okay, when I multiply them together, I get a number that's much bigger, or has, I think, 4 spots after the decimal point. But I can only have 1 because I only have 3 here. So I'm going to do 15.2 centimeters squared. That would be my answer. Okay, so those are Sig Figs. They are important in chemistry. They will definitely be counted randomly on the AP chemistry test. So they're important to use, and we're going to start using them beginning of the semester. Woo! So if you guys have any questions or comments, or you want to have a video about something even more specific with Sig Figs, leave a comment below. And you guys know how to contact me through my email address. And look forward to a new video. Peace out, Girl Scout.